So these are, we'll have the slides up as well as the GitHub repo for this workshop. So at any time you can like refer back to these slides or go to the repo to get the code. So yeah. Oh yeah, so yeah, this is being recorded, FYI. Informed consent.
Yeah, chat gets recorded too, just so everyone knows.
Also, just like last workshop, we have a REPL, so you don't actually need to like download all the Python stuff. We'll be using REPL. So.
Yeah. Okay, so as a recap from last time, we'll be going over what we learned in the last workshop, which is mostly data types and different control flows. So last workshop, we learned about the different data types available in Python. So variables can take on a number of different types of variables or values. So we have ints, which is just your standard integer numbers, such as 0, 1, -1, anything between the range -2 to the 31 and 2 to the 31 minus 1. And you also have your float variables, which are basically decimal values, which is like 0.5, -3.4, -3.0, anything that has like a decimal point within the number. We also have strings, which are a sequence of characters, which can represent any like different text. So we can, in Python, we're able to use single quotes or double quotes, so it doesn't really matter. So examples like shown here are like hello world. You can actually use 1, 2, 3 in text as a string, and as well as like hack school is great. And another data type you can find in Python is called a Boolean value, and this is your standard like true or false, so either yes or no, 1 or 0, on and off. And so in Python, it's written as true or false with a capital T and a capital F. So compared to other programming languages, Python is unique in that the first letter is capitalized. And next, we have different types of control flows. So the first thing we'll be going over is conditional statements. So what this means is that different blocks of codes are executed based on whether or not a condition is fulfilled or not. So these statements are known as your if, elif, also known as else if, and your else statements. So how this works is you'll have something like this, and basically the code branches off into different blocks of code based on which conditions are fulfilled. So if condition 1 is fulfilled, then you would execute the code within this block. Else, if condition 2 is fulfilled, then you would run the code in this block, and else you would run the code in the final block. Now, you have to note that even though multiple conditions are fulfilled, the if, elif, and else block goes in order based on conditions. So even if condition 1 and condition 2 are both true, it only executes the block in condition 1. And so another different type of control block that we have are called loops. And so these are what you'll be using to sort of iterate over different blocks of code in a repeated fashion. So for here, you have a variable such as basket, which holds the values apple, banana, and cherry. And so we have what's known as a for loop, which runs code a certain amount of times. So we have 4 fruit in basket, and each fruit that we have in the basket will print out that fruit. So in this case, this block of code right here will print out apple, then banana, then cherry. An other type of loop that we have is called a while loop, and this basically runs indefinitely until one of the conditions that the while loop sets is fulfilled. So here we have I equals 0, and so while I is less than 5, we're going to print out I and then increment I by 1. So here, each time we go through the loop, we're going to print out the value of I. So the first iteration is going to print out 0. Then we're going to increment I, so then it's going to be 1. So then we'll go back to the loop. We're going to check to make sure that I is less than 5, which it is since 1 is less than 5. And then we'll print out I again, which this time it's going to be 1. So this is just going to keep going until I is no longer less than 5, which is when 5 is not less than 5. So at the end of this, you'll have something like 0, 1, 2, 3, 4, and the final value of I will be 1, or would be 5. And so now we're actually going to start getting into some new stuff. So last workshop, we really didn't go over what Python really is as a language. So Python is known as a strongly typed language. And what does that mean? It basically means that the operations you perform on a certain variable type, you can't perform those on something that's a different variable type than what it was intended for. So here in this example, you have a variable called data. So first we assign it to a string type, then we assign it to an int type. And then what we try to do is add it to a string. And this doesn't work because in Python, you can't add a string to a number because that doesn't work. But also notice that Python is a dynamically typed language. So up here, you see that first we assign data to a string type, but then we also reassign it to an int type. So that's because the picture got messed up. So basically in Python, what happens is that the variable types are actually assigned in runtime. So what happens is that when the code is executed, that's when variables actually get stored with their respective values. And so in Python, what happens is that it's not the variable itself that has a type, it's actually the value that has the type that the variable stores. And so if you can see the picture right here, it's like declaring a variable. We don't do that in Python. And so another thing that we have to talk about when it comes to Python is the difference between an interpreter and versus a compiler. So both of these are what people use to run their programs, but they do so in different ways. So interpreters run their source code directly one line at a time, while compilers first scan the entire program and then translate it to code that you can run via an executable file. And so because of this, interpreters actually take longer to execute because they run the code line by line, while compiled code or compilers, they scan the entire program, which might take a while, but in the end, you get this executable file that you can run basically at any time for as many times as you want, and it will usually have a faster runtime than if you were to run it with an interpreter. And so another thing that because of this difference between interpreters and compilers is that interpreters usually stop on the first error because they run line by line, while compilers actually wait until they scan the entire program before outputting any errors within your code. And one last thing to note is that Python is one of those languages that uses an interpreter. So now we're going to move on to functions. So we briefly learned about functions in the last workshop. They're basically pieces of code that you can run that have like an input and an output. And so usually these pieces of code are pieces of code that you can usually run multiple times. What you do is you call the function with a certain input and it outputs the value of what that function should be doing. And so you can actually relate this to the functions that you have in math. So up here we have a picture. It's kind of hard to see, but you have your function, which in this case it's called f, and you input a certain variable x, and you output, say, x squared. So yeah, functions are a really big part of programming in general because it helps simplify code by separating it out into different blocks. And yeah, basically functions are just really useful and you'll be using them a lot during your time programming. So this right here is what a function looks like. So we have this function called takeCourse, and what you input into it is a name and a course value. So what the function does with those values is it prints out the name, then it prints out the string is now taking, and then it outputs the course as well as an exclamation point. So if we print out, or if we call takeCourse Henry CSE 101, we call this function, and basically what this function will print out is Henry is now taking CSE 101. And so notice that for a function, you define a function with the def keyword over here. This basically signifies that this is a function. And so another thing that you can do with functions is that you can also call other functions within your function. So you see right here, we actually have the print function right here. This is an example of like calling a function within this outer function. And so basically we're going to deconstruct what this function actually is. So these up here, the name and the course, these are your parameters. These are sort of like placeholder values that you define within your function to act as basically variables that you use within your function to run the code. And what you're actually going to pass into your function are what are known as arguments. And these are the actual values that you'll be using within your function. So, as a question, what will happen if we change the values? So say we call take course CSE 30 Shrubbing. So yeah, Thomas got it. Basically, if you change around the values, it will actually print out CSE 30 is now taking Shrubbing. So the order in which you actually input the arguments actually does matter because it's based on the order of the parameters when you define the function. So we're going to get more into actually like what you can do with functions. So with functions, you can actually return different values, and this would be your actual like output. Before we saw that when we printed out the statement, it would send out like printed out text. That's one way of outputting a value, but you can also just return a value straight from the function. So here you have a multiply by 3 function, which takes in a number, which is usually going to be an int value. And what it's going to do is it's going to create a new variable called new num, which takes num and multiplies it by 3. Afterwards, it prints done and returns new num. So when we call multiply by 3 with 2, and then we print out what that function returns, what will happen? Yeah. So what this function is going to do, we're going to call multiply by 3 with 2. 2 is going to go into the function. We're going to assign it 2 times 3 to new num. We're going to print out done, like Thomas said, and then afterwards we're going to return new num to this function, and then we're going to print that value, which is 6. So yeah, Thomas is right, and it would print out done and then 6. And so basically right here, you see that return is what you use to actually return a value. The return keyword is what you're going to be using to actually display what your output is. And so in case we don't want to return anything, and in case we just don't want anything in our function, we can also just have an empty function using the pass keyword. And this is basically just saying like pass, I don't want to write anything for this function. Because basically Python sends an error when a function is empty. So if we have an empty function, we're going to want to use pass in order to make sure that the function doesn't output an error. And so I'll give it over to Shravan to take it over.
Yeah. All right, so now we'll talk a little bit more about import statements. So in the first workshop, we kind of introduced importing different packages from other developers. So now we'll talk about like creating your own packages and modules and how you can use your own functions in different files. I needed to steal a presenter from you. There we go. All right. So a little bit of terminology here. So we have modules and packages. So modules are basically just any Python file. So they could be built in, which is like what Python comes with, or they could be your own .py files. And from these files, you can import functions and variables into your own code. So basically, when you're developing Python applications, usually it's best practice to separate functionality outside of different files. So let's say you need to call a function from one file that exists in one file in another file, then you can use importing to import those specific functions. So packages are just collections of collections of modules. So a package is basically like a directory where the module is essentially a file. And you can import packages. You can import separate modules from packages to be able to access all those functions and variables like in that module. So pip is the Python package manager. So this is you use pip to install packages made by other developers, and you can find those packages on online, and they're like wildly useful. They're used for like web development and like web scraping and all that kind of stuff. So we'll go into pip more in future workshops, but simple syntax to install packages would be just pip install and the package name. So a little bit about the package structure here. You see that we have like an init.py. So this is like optional pre-packaging instructions. So ever since Python 3 was released, init.py has become optional, where previously it was mandatory. But it's basically like whenever you have an import line in your code, those instructions will run in the init.py from the package that you're importing. And then these two will just be modules. All right, cool. So let's take a look at how we'll import stuff. So over here, we have like 3 different cases. So here is where if you're in a file in the same directory and you want to import a different file, like so they can use those functions and those variables, you would do import module, where the module is the module name. So you can access every function and every variable inside module because there's no scope in Python. So you can do module.var if var is a variable in module, and you can do module.function. These are both legal things, assuming that var and function exist in module. So here we have the syntax from module import function. So this is used if we want to import just a particular function in a module and not like everything in that module, which would include like other functions and variables. So this would be like a more efficient way and like less clutter on the overall like namespace. So here you'd be able to call function legally, and you wouldn't have to be typing like module.function. But here you can see we actually can't print var because we've only imported function. So you'll get an error. So here we can import a module from a package. And you can see we have these as keywords. And that's if you want to shorten the module name to be MD. And yes, you can do from module import var. So here we have md.function and we have print md.var. So the md is just like a shortened word, and you'll see like this type of syntax in like many web development and like machine learning projects. So it's just like a shortened syntax, and you can access all these variables legal. Yeah, like import pandas as PD and like TensorFlow as TF. Yeah. All right, cool. So let's talk a little bit more about data structures. So we introduced lists in the first workshop, but now we'll go into more detail about dictionaries and sets. So data structures are basically just containers that hold data, and different containers and different data structures serve different purposes. And we'll kind of analyze the different purposes of these 3 data structures here. And a linked list is also a type of data structure, like quality meme. All right, cool. So first we have the dictionary. So the Python keyword is dict. And what a dictionary is essentially it's a structure that holds data in key value pairs. So think of a dictionary like an actual English dictionary. So if you look through an English dictionary, you have words and you have definitions. So the key would be the word and the definition would be the value, or the value would be the definition. So Python syntax to initialize a dict would be, you can use empty curly brackets, or you can use the dict with 2 parentheses. So here's some dict functionality. These are functions that and like paradigms that you'll use a lot when you're using dictionaries. So here we would see dict and brackets key equals value. So this is basically just creating a new entry in a dictionary. You don't have to use like .add. Here you can just assign the index to the value and it'll create that entry. So here we have dict.pop. So this will essentially remove an entry from the dictionary and it'll return the value. So you can remove by a specific key and return that value. Keys just returns a list of all the keys that are in your dictionary, and values returns a list of all the values. And dict.getKey, default is very useful if you're trying to get a specific key in the dictionary, but if you don't know it exists. If you want to access a key that doesn't exist and you use this syntax, it'll throw an error. But here, it'll just return the default value. So no errors will happen. So here we can look at some example code using dictionaries. So we have 2 students. We have Don Joe, and here's his social security number if you guys want it. And his favorite OS is Linux. See, Don Joe is a good guy. Here we have student 2, Beth Jezos, and his social security is 5, and his favorite OS is Windows. So that's why he's student 2 and not student 1, because his favorite OS is Windows. So learn from Don Joe. But anyways, these are two dicts here, and the keys are name, SSID, and favorite OS, and the values are Don Joe, this number, and Linux. So here's some functionality we can use with these two students. So we have student 1 OS, and we can pop the key favorite OS from student 1, and we'll get the value Linux. Likewise, we can pop the SSID value from student 2 and get the number 5. And here, we're trying to access an ID keyword, ID key, but it doesn't exist in student 2, so we just get the value 0, which is the value here. And here, we would get the values of student 1, which are just all these. And important thing to note is these values may not be always in this order because of the way dictionaries internally work. They use like a hashing function where the order that you insert an item into the dictionary will not always be the order it's like present there. So it's something to keep in mind. Okay, so another wildly important data structures is set. So a set is just an unordered collection of unique elements. So for example, we can have a set of cardinal directions like west, east, south, and north. So here, a set may be like fairly similar to a list, but you can see a couple differences here. So for one, a set is better for checking the existence of an item. So what does that mean? So sets, like dictionaries, have a hashing function as well, where you insert a key or you insert a value, and it'll be hashed to a specific number and stored there in memory. So a set is better to check existence because you can check existence like very efficiently. Like if I want to check this value, I just check if that index happens. I use the hash and check if that index is there. And if it's not, then the item's not there. While as a list, you would have to iterate through every single element and see if that element is there. And if it's not, then you return false there. But that's where the list is less efficient and the set is more efficient. So here's some set functionality. It's like pretty simple. The essential tools are just adding, removing, and checking membership. So you can add an item by doing set.add item, and you can do .remove item. And some examples here, you can create a set with an empty set like this, and you can add some sports to it, for example. And by the way, I think coding is a sport because our eyes are freaking jacked. Like, we're getting a serious workout on our eyes. So this is a workout right here. So when you print sports, like a dictionary, it doesn't print in the same order you insert it. So it could be any random order. And we can remove an item and then print again with that item removed. And this will check membership. And you can see that swimming is not in sports, so we return false. So what better way to practice our data structures than with some Leetcode? So for those of you who don't know Leetcode, it's a platform online where you can practice programming questions and prepare for your technical interviews. And this video is not sponsored by Leetcode. We're just going to do some Leetcode here. So we can like check out this link, and I'll like share my screen, and we'll go through a problem together. Yeah. So, okay. Ooh, recursion. Let's go. All right, cool. So we're gonna do two-sum today because it's like the classic problem. Also, you guys can see my screen, right? All right, yeah, you can see it. All right, cool. So yeah, we'll be doing some two-sum today, and two-sum is a great problem to see how we can use data structures that we've mentioned before to like optimize a problem. So what is two-sum? The question states, given an array of integers, return indices of the two numbers such that they add up to a specific target. So basically, and you can assume that each input will have exactly one solution, and you may not use the same element twice. Okay, so if we look at the example, what it's basically saying is we're given a target here, and we need to return two numbers in the array that add up to that target. So here you can see some Python 3 syntax with classes. We'll go over classes later on in the presentation, but here you can see functions that Henry mentioned. And here's a little bit of the strongly typed nature that Python has, even though it's like technically weakly typed. Like you can see that you can assign types to function input still. So nums will be a list of integers, and target will be an int. And this function will return a list of integers. Okay, cool. So how do we want to solve this problem? I guess one of the like initial intuitive approaches is to just like search every possible combination of two numbers in the array, and if one of them equals target, then we return true, or we return those two indices, because we want to return the indices, right? So we can go ahead and actually code that right now and see what happens. So how do we do this? We'd want to use like 2 pointers and try to basically iterate through the entire array and compare each two numbers and see if they add up to target. So it'd be something like this. So for I in range and then length of numbers, so this is just a standard for loop, and then for j in range, so we want to do from I to length of numbers because we want to start at, or we want to do I plus 1 to length of numbers because the instructions say that you cannot use the same element twice. Also, an optimization thing, you can see that we're calling length of numbers twice here. So instead of calling the same function multiple times, we can store the value as length of numbers since it's not going to change, and then just use length here. Length here. Right? So now we have I and j. So we want to compare if the two numbers add up to target. So if nums of I plus nums of j is equal to the target, then we return, and we want to return a size 2 array of the two indices. So we want to return I and j. And so basically we already know that every input has exactly one solution. So we technically don't need to return anything out here, and Python will consider it legal. Like even though the return is in the for loop, there'll always be a solution. So you can return anything you want here. Like you return like I like love ACM or something like that, and it'll be perfectly fine. So we can go ahead and run this code and see what type of answer we get. So we get the right answer, and we can submit it to see all the possible, if we get the solution right. You can see like all my attempts got a wrong answer here, but yeah, we solved the problem successfully, but our runtime is like really ridiculously long. Like that's a lot of milliseconds. Like I can't count that. Like that's a big number. So the question is, how do we optimize this? Like how do we bring down our runtime as low as possible? So you can see here, I already kind of revealed it. Like we get it really low, but you can see we use extra memory. You can see like our memory usage goes up, and this is because we'll be using one of the data structures. So let's look at the problem again. We want to figure out how we can use some sort of data structure to optimize our problem so that we don't have to loop through every single element, right? Because we don't actually have to loop through every single element. Like that's really redundant, and like we can optimize it so that we only need to loop once through the array. So the question is, how do we do that? Well, if we think about what a sum is like a plus b equals sum. So if you think about it, if we store every element we see in a dictionary, and we store the value as its key and the index as the number as the key and the index as its value, then we can see if any of these numbers is the sum minus a number that we've seen in the dictionary. So like here, our target is 9, and we have 2, right? So we'll put 2 in our dictionary, and then we'll check 7. So 7, so basically we want to check if target minus our number is present in our dictionary. So we see that 9 minus 7 will be present in our dictionary once we use it, so then we'll return 2 and 7. So that's kind of the intuition we'll use. And this is more efficient because lookups in dictionaries are very efficient. If you know time complexity, it's O of 1 time because it uses a hashing function. But if you don't know time complexities, just think of it, it's like really efficient lookups. So we can go ahead and code that right now. So we can keep track of like a scene as an empty dictionary right now. So if you remember, this is the syntax to create an empty dictionary. So now we can traverse through our numbers. So for number in nums. So with for loops, we can do for loops like this, where number, you don't need to specify a range. If you specify an array here, it'll just be the number. But we actually also want the index. So what you can do is inum in enumerate nums is like a fancy way to get the index and the element. But again, we only need the index, but I just want to like show you this as a way, like we can do enumerate to get both the I and the number. So now what do? Like I mentioned, we want to check if the sum minus our element is in the dictionary. So we can get, I think it's called addend. I don't know if that's like the terminology, but like we can get the addend as our target minus number, right? And if our addend is in our scene, if we've seen our addend, like here, our addend at 7 is 9 minus 7, which is 2, and we've seen 2. So we return the indices, right? So if addend is seen, then we want to return the first index, right? So 2, we want to return the index of 2. So we want to return scene of addend. So this basically gets the value of the key that is addend. So we'd get the value of 2, which we'll store as 0. I'll write the code for that later. But we want to store the index as the value. So here we have return scene of addend, comma, and then I. Because we're currently at 1, and we want to return 0, comma 1. So if we don't see it, then what do we want to do? We want to add it to our dictionary. So we want to do scene of number, right? So if we've seen the number, we want to set that as I, right? So basically, if we're at 2 right now, let's say, and our dictionary is empty, so this won't run. So this if statement won't run. So we'll be at scene of number equals I. So we'll set scene of 2 equal to 0. And then we'll move on to 7. So again here, since the problem guarantees that we'll have a solution, we can return anything outside. Like you don't need to return anything. You probably like in your interviews, you shouldn't return I love ACM. But like here we can do it because this will always trigger. So you can return anything out here. Out here, it could be like, it should probably be a list because we want it to return a list. So we're just like, I love ACM, right? So here, okay, this code should work, hopefully. Yeah, you can see, all right, so we can submit it this time and see what happens. All right, here, cool. So we see we're at 48 milliseconds now compared to 5,844. And we're at 70. We beat 77% of Python 3 online submissions. So yeah, that's like a short little demo of how we can use data structures to write like more efficient code. So yeah, head back. All right, cool. Does anyone have any questions? I'm assuming like people are answering here. But yeah. Unfortunately, we are not covering the Wallace operator. I can tell my superiors to potentially cover the Wallace operator in future PowerPoint presentations, but we'll see about that. Yeah, we'll stop sharing this. Wait, ooh, you see that recursion? Damn. Okay, so a question is, what was in your dictionary? So what was in our dictionary was basically the array, but like in a dictionary format. So the key was the number, like the number that we've traversed through the array, and our value is the index. So the whole reason we want to use a dictionary is because we have very efficient access to previous elements, right? So what you saw in our initial solution, we had 2 for loops, and we had to iterate through like every single element like multiple times. And in an array, it's very inefficient because you need to traverse through everything. But if you're using a dictionary, it's very rapid. So that's the whole reason we want to use a dictionary. Even though the functionality of the dictionary, like the purpose of the dictionary and the array are the exact same thing. Like they both store elements at indices. It's just we need that efficient lookup time to lower our efficiency, to lower our time, runtime. Yeah. Okay, cool. Let's move on. Okay, so now we'll go over classes and objects. So what classes and objects are is basically a way to create your own containers of data. So we've seen previous containers of data, including dictionaries and sets and lists. So here we can create our own classes to have like serve our own functionality that we need. So yeah, we can have different functions and data fields in classes. So classes are part of something called object-oriented programming, where basically you solve problems using objects. So in object-oriented programming, functions are called methods. So you'll see that terminology a lot. And we use objects to represent the actual container, while classes are like the blueprint. And here's SpongeBob. Yay. Okay, cool. So let's take a look at a class for now, and then we'll dissect it and see like what is actually going on. So sorry if this is like small, but this is basically an entire class, and this is where we're checking our functionality for our class. So here you can see we define a class like class student. So if you saw in the Leetcode thing, they had like a class solution. So similarly, we define a class like this. So here we declare a new class named student. And here we have a couple functions. You know they're functions because they have the def in front of them. So here is something funky. We have underscore underscore init underscore underscore. So that's like a wacky name, right? So it must serve some kind of purpose. So this type of function is called a constructor. So those of you who are familiar with Java, it's like the same thing. It's basically just defining. It's basically how you like declare your variables and initialize your variables. So what this means is we can think about what our student object needs, what our student class needs. So let's say for now we have 3 fields. We have name, courses, and clout, because this is everything that students need, right? You just need a name, you need classes, and you need clout. That's like all you need in life, all right? So this self thing is all over the place. So self is it's a Python concept that I'll be able to explain later once we go through our examples. But think of it right now as we need it. And when we go through these examples, I'll like kind of explain what self is. So here we have 3 inputs along with self. We have name, courses, and clout. So we can pass in values of those variables, and they'll be initialized to our class. So here we have 2 more functions. We have add course and send funny meme. So these functions or methods don't have any return values. We'll just modify the fields that we have in our class. So add course will just take a course name and it'll append it to our courses. So one issue with Python you can kind of see is like you have no idea what types these are. Like they could be anything. And like here you wouldn't know that courses is a list until you see this append thing. Which is why like Python 3 tries to like fix that with being able to show typings like it did in the Leetcode thing. But here you're basically adding a course to your courses, and send funny meme will increase your clout by 1. Yeah, so those are our functions. And we can take a look at some examples. We have student 1 and student 2 again, but they're different people. So we have Tommy, and you can see courses is a list with CSC 13, Cat 4, and Math 20G. And we have a basis clout of 10. See, I'm a fair guy. I give everyone starts with the same amount of clout, all right? And then you can up that as you go on in life. So basis clout is 10. Okay. So student 2, we have Gertrude, all right? And she's taking CSD 15W, CSD 1004, and Phys 140L. So this is her name, her courses, and her clout is 10. Okay. So here we can get our student 1 name by typing student1.name. So we can access like the name field of a particular student or a particular object by referring to the dot, yeah. Like you access the name by using the dot. Like you can see it, name is defined here. So student 2, yeah, dot operator, thank you. So here we have student 2 dot add course as muse18. So here I'll go ahead and explain what self is. So you can see that we aren't actually passing anything as the self. This is because actually student 2 is passed in as self. So the way Python knows to add specific names, specific fields to specific objects and not other objects is through this self thing, this self field, right? So every function or every method in a class needs this self so that Python knows which object to change that value of. So here, you can think of it as add course of student 2, comma muse18. And then here, we can use the same dot operator that we used over here to access its courses and then append a course. So here we're appending muse18 and we get student 2 courses as this now. But keep in mind, we're not actually returning any value here. This is just the value of student 2.courses. So here we have student 2.sendFunnyMeme. So again, this doesn't return any value, but basically sendFunnyMeme is called while student 2 is passed in, and student 2's clout will be increased by 1. So student 2 just dunked on student 1 so hard with that funny meme, so student 1 is just deleted off the face of the planet. So you can delete a student object by calling the keyword of using del and student 1. And this means that you can't access student 1 anymore. Like student 1 is not an object anymore. So that's what the del keyword is. So any questions? I'll like go over all this stuff in the next slide if you want like a formal way. All right, cool. So let's do a quick recap on classes and objects. So again, classes are blueprints for objects or containers of data, right? So every class needs an underscore underscore init underscore underscore, and it's used to construct new objects. Like that's how you create and initialize new objects with certain values. Thank you, Elias. And okay, so classes also have methods, right? So again, it's called methods and not functions because it's like an object-oriented programming paradigm, right? So this is how you manipulate data fields in the object or in the class object. Yeah, object. And they can have return values or they don't need to have return at all, or you can just call pass, like Henry mentioned in like functions before. And again, we need the self as the first parameter for all methods inside a class so that an object can be passed in to manipulate. So I know self is like kind of a weird concept. If you're familiar with languages like Java and C++, it's kind of like the this keyword, except it needs to be like a parameter in every single function. While in Java and C++, it's like an implicit parameter. It's like not always, you don't need to define it, but it's like implicitly there. So we have objects now. Objects are just instances of classes that hold data. And you can initialize and create as many objects as you want. Like we had 2 students. You can have like an infinite amount of students or like however many students like your memory can hold. And each object has their own like personalized data fields that are defined in the class. So it's like a super powerful tool to like replicate multiple objects or store like different objects such that each of them has different fields. Any questions? All right, cool. So now let's go ahead and create our own classes. So I have a link to a REPL over here, and I'll go ahead and share my screen again. We'll be all collectively building a class together and initializing some objects. So I'm going to need your guys' help. But yeah, I'll go ahead and share my screen. Ooh, recursion. Ooh, you see that? All right. Okay, cool. So here we have two files, and if you want to code this yourself, and not on this REPL, there should be a fork button right here. It's not there for me because this is the REPL on my account, but you should be able to fork it to your own like account or to your own like session, and you can code there. So we'll be building an ACM member class together. So I'm going to need your guys' help to define different functions, different fields that we need, and to test our ACM member class. So Henry's going to help me read all of your suggestions that you guys have because I can't really see like the chat right now. So feel free to comment like any fields or any functions that you guys want. So let's define our constructor right now. So if you remember, it's def underscore underscore init. You can kind of see this autocomplete here. Args and quargs are optional fields that are like more advanced. But here we can define self, and we can define some fields here. So Henry, do you have like, are there any suggestions in the chat?
So Thomas said one of the fields should be a Boolean.
Okay.
Liked code.
Liked? Okay.
Like to code.
Oh, like to code.
Yeah,
Like likes to code? Okay, got it. So I'll be like likes to code. All right.
Yeah.
Any more fields? It could be anything. It doesn't need to be like
member points.
Member points?
Yeah.
Okay.
Name.
Sorry?
Name.
All right, yeah. Probably need a name.
Clout.
Clout, yeah. We all need clout. We'll do like two more.
Social, SSN, social security number.
All right. One more, just anything. Doesn't need to be logical at all. Just like anything.
Let's go with Boba's consumed.
All right, that's very realistic. Boba's consumed. All right, cool. So here again in the constructor, we want to assign all our variables that we're passing in. So when we create a student or an ACM member object, we pass in all these fields. So we need to define and initialize those in the class. So we can do self.likes2code equals likes to code. Self.member points equals member points. Self.name equals names. Self.clout equals, okay, clout. Self.ssn equals ssn. Self.bobas consume equals like. All right. So here we have our constructor. So we've defined data fields in our constructor. And also just a quick thing over here, you can see that we can actually use pass on classes too if we don't want to like actually define any functions or fields yet. We could just use pass and like the Python won't complain. All right, cool. So now we need some methods so that our ACM member can do things, right? That could potentially change their member variables. So do we have any suggestions for potential methods for the ACM member? Henry?
Let's see. We got walk to 6th.
Okay, we got def walk to 6th. And does this function? Okay, so this method needs self, but do we want to pass in any fields? Are we changing any fields? I personally think walking to 6th provides huge amounts of clout, so we can pass in some clout here. And anything else? Would you guys like any other fields? Is that good enough?
I think I just want to move on to other functions.
All right, cool. So we'll just clout self.clout plus equals like 500 for walking to 6th. All right. What other functions do we have?
We got get boba.
All right. So I'm assuming we're getting an amount of boba. because usually we don't drink just one drink, right? We drink like as many as we need to. So we'll get like a number of boba, like amount of boba. And we can self.boba is consumed plus equals the amount of boba. So the plus equals is just like a shorthand for saying like self.boba is consumed equals self.boba is consumed plus amount boba. All right, we'll take 3 more functions.
3 more functions. Okay, we got host workshop.
All right. What kind of fields do we need? If you're recommending functions or methods, by the way, like say like what types of fields you want, or like what you want it to do. So like host workshop. What would host workshop do? We'd be like, you'd probably consume boba if you host a workshop.
Host workshops increases clout.
Sure, we'll take that clout. We need as much clout as we can get, right? All right, so I'd say this is 1,000 clout. That's a reasonable amount. All right, 2 more functions.
Also for host workshop, increase consume boba and increase membership points.
Gotcha. Self.boba's consumed plus equals, say at least 5. All right, and let's say self. What was the other one? Member points.
Yeah.
We'll do 10. We'll do a reasonable amount. All right. 2 more functions. Methods. Sorry.
Let's do delete SSN.
All right. Delete SSN. Self. So I'm assuming there's no input field. So we'll just like self.ssn equals 5. You can become Beth Bezos. All right, cool. We'll do 1 more.
Okay. Go to kickoff.
All right. Go to kickoff. I'm assuming this doesn't. So if you go to kickoff, I assume you like to code. So we can set likes to code equal to true. And we can increase our member points by was it normally like 100 or something? 50? I think 50. And we can change. No, we won't change the name. We could do boba's consumed because you get at least like 2, right? At least 2. All right, cool. So these are our methods. Sorry. If I say functions, that's my bad. These are all like supposed to be methods. It's just the terminology. But so here we have our complete class. We have different member fields or value like variables, and we have different functions. So we can go ahead and test our ACM member class. I'm in the main.py. I'm gonna go ahead and copy this because I'm gonna forget the order, and just like comment that here. So yeah, this is the order of the parameters we need. Because again, if you saw in Henry's example, if we like switch up the parameters, then things will get like real messy real fast. So how do we actually access our class, right? That's the question. And we can do that by importing. Like if we were to write our logic here, then we wouldn't need to import anything because it's in the same file. But since it's in a different file, we need to import our ACM member class. So what we can do is from ACM member import ACM member. So we're importing the class ACM member. This class is being imported. So we can go ahead and create objects. So these objects will be students. So I'm going to ask again, would anyone like to be objectified for this demo? Would anyone like to be an object? Just like, I'll like use your name. So
Elias.
Elias?
And Elias.
I bet. I'll do Bryce. So let's make Bryce equal to a ACM member. All right, Bryce, I have a question for you. Do you like to code? I'm
Answer that's a yes.
That's a yes. All right, gotcha. So we'll say that's a true. Member points. You have like at least 700, bro. So I'll just say 700. Name, Bryce. Bryce. Clout, Bryce. How much clout do you have? Are you keeping track of that?
All of it.
All of it? All right. We'll say at least like 20,000. Bryce, I already know your social security, so you don't need to tell me that. It's 2. And then Boba's consumed. I'm gonna say like probably 100 minimum. All right. So let's go ahead and take Bryce on a test drive. All right. So we can go ahead and call different function or different methods on the ACM member and see like if we can change the values that Bryce has. I'll create Elias in a second. We'll do that in a second. So again, these are our functions, our methods. Sorry. We have walk to 6th, get boba, host workshop, delete SSN, and go to kickoff. So let's make Bryce walk to 6th. So we could do Bryce dot walk to 6th. And oh, do we take in cloud? Oh, we take in cloud. Wait, I don't know why we take in cloud. We won't take in cloud. You can't earn clout other than the clout you're getting 500. So we Bryce dot walk to 6th. And here, what we can do is print Bryce's initial clout and his final clout. Bryce dot clout, right? And now we can walk to 6th and print his clout again, Bryce dot clout. So we can go ahead and run this. It'll take a second, but you can see Bryce has indeed been cloudified. His clout has been increased by 500. All right. So Elias was next, right? We'll do like 2 more people after that. We'll call like different functions. So Elias equals ACM member. I already know Elias doesn't like to code, so we'll do that as false. What's our next field? We need member points. He hasn't been very active recently, so like probably 100. We got Elias. Elias, do you know how much clout you have? What does your clout meter say?
It's negative 1,000.
Negative 1,000. Gotcha. Not doing too hot there, man. You gotta walk to 6th more. We have social security number. Elias, what is your social security number?
One, two, three, four, five, six, seven, eight, nine, 0.
All right. Dang, you got 1 extra digit, man. And boba's consumed. He doesn't drink boba. All right. So let's call a different function on Elias. We can do he doesn't get boba. We can make Elias host a workshop, right? We have multiple fields changing here. So we can do Elias dot host workshop. And why are we passing in cloud again? We don't need to pass in cloud. But we have host workshop as self, right? Or do we need it? Yeah, we don't need to. Okay, cool. So let's measure Elias's clout again. Or we already measured Bryce's clout, so let's measure something else. What are we changing? Our boba's consumed. Dang, Elias is losing his boba virginity. Yikes. Anyways, we have print Elias dot boba's consumed, and then print Elias dot boba's consumed as a before and after. And you can see that Elias has finally drunk boba, and he's probably on a sugar high right now. Well, we'll do 1 more person, because like I think you guys are like starting to see the idea. Like we can access different functions or we can access different member fields, and we can call different methods on our objects. So, Henry, do we have 1 more volunteer?
I think Thomas said he wanted to volunteer.
All right, cool. Thomas equals ACM member. Thomas, do you like to code, my good sir?
Yes.
All right. Member points, probably like 1. We got name, we got Thomas. Clout. Thomas, what does your clout meter read to you?
4.
4. Gotcha.
Oh, 42.
42? Nah, you're stuck at 4, man. There's no changing that. And we got SSN. Wait, do I have an extra field? Oh, I have. Do I have member points? Okay, likes to code, member points, name, clout, SSN. Okay, cool, we're good. SSN, it's probably like 70. Bo is consumed, actually negative 70. Bo is consumed like, there we go. And you're complaining. Why are you complaining? Just like 2. That's too much boba. Python can't handle that much boba. Thomas, you gotta tone down, man. Anyways, so we'll call a couple functions on Thomas. We can make him go to kickoff, and we can delete his social security. So Thomas.go to kickoff, and because you went to kickoff, your social security is gone. Delete SSN. So what do these things change? So we set likes to code to true, member points plus equals 50, and Bo is consumed. So we can check your member points. So we have our print, and let's print a string this time. So we can say like Thomas's. That's a lot of S's, bro. Thomas's membership points were, and then here we can print our variable, but first we have to cast it to a string because, like Henry mentioned, you can't do a string plus an int. Like Python will not allow that. But if you cast the int to a string, then you can do that because it's string plus string. So your membership points were Thomas.membership member points. So you can go to kickoff and delete your social security. And now we can go ahead and print Thomas's membership points are now plus a string of Thomas.member points. And then print his SSN is plus string of Thomas.SSN. So you can see that because he went to kickoff, his points were increased, and his social security number is 5. And an important thing to note, like once again, this shows like the power of objects and classes. Like none of these values were changed. Like these are all like independent objects that each have their own member fields, which are unchangeable by calling other objects. So I hope this demo was like showed you guys a little bit more about the power of classes and like creating your own different data structures, like data containers that you could use for your own projects. So yeah, that's it for the demo. I'm sharing my screen. Recursion. Woo! No problem, man. All right, cool. What's next? Oops, I don't want to draw that. Oh, okay, that's it. Yay, we're done. So yeah, that was basically it for the workshop. We hope you guys enjoyed. We hope you guys had a good time. So our next workshop will be on Python development. Daniel, if you want to say something, you can too.
So next week is we're going to start doing more like workshops that focus on the applications of Python, and we're going to start with web development part 1 next week, which I believe is taught by Henry and Paul. So come out to that and I'm gonna unmute everyone or unlock everyone so we can give Henry and Trevin a round of applause. So let me do that real quick. Okay, you can unmute and you can clap to them because that was a good workshop. I'm gonna clap.
Oh hell! Clap, clap.
Or you put clap in the chat. That works too.
Thank you.
Oh yes.
Beautiful.
Yeah.
Thank you.
Thanks, y'all. That was good. All right. I'm gonna stop the recording.